Hello, everyone. Hello, everyone. Welcome to the extra lesson. On Friday, I think I explained the last two homework assignments. I mentioned that some students didn't do the differentiation using the best method. And if you find yourself getting a minus, probably because one or two questions, your methods were too difficult. Now you can watch back the video I made. I think I did a video for Friday's lesson. Now on Friday, we also explained a new bunch of rules. The rules for differentiation of trigonometric functions. That is ddx sine x equal cosine x, ddx cosine x equal negative sine x, and ddx tangent x equals secant x squared. Now the proofs are basically using first principles. There are other ways. If you read the textbook, there are other ways, but as a revision for first principle, I showed during the lesson how to do that using first principle. Now, if you were absent last time, maybe you need to watch back the video. My suggestion is to watch back the video. And then the classwork last time. I don't know if you have finished, but I'll show you the answer very quickly. A dy dx equal secant u squared, and then du dx. So 1/3 secant squared x over 3. Part B, dy dx. This one has 3 layers. So the first one is 2u. And the second one is negative sine 3x. And the third one is 3x differentiation. So this one is 2 cosine 3x, negative sine 3x times 3. Final answer, negative 6 cosine 3x sine 3x. Last one, dy dx equal d high low minus d low high divided by low square. And it's equal to 4. Should I expand? Maybe I shouldn't. It's 2 sine x cosine x, 2 minus cosine x minus sine x cubed, 2 minus cosine x whole square. And then you really need to learn how to simplify. I think half of the lesson should be focused on how to simplify. Now I will take out sine x. And you're left with 2 cosine x times 2 minus cosine x minus sine x squared, and 2 minus cosine x whole squared. And then I'm left with sine x. And then this one is 4 cosine x minus 2 cosine x squared minus sine x squared. Maybe like that. Now just make sure that it's all factorized and each factor is simplified. Now for this factor, I think it's almost okay. It's just a little bit uncomfortable for me to watch sine square and cosine square at the same time. So I will just use it. I will just use the square identity again. That is negative cosine x squared plus 4 cosine x minus 1. 2 minus cosine x whole squared. I think. If your answer is different from mine, compare ours, compare our answers, and decide for yourself now which one is simpler. If you don't know, let me know. Example 17. dy dx at x equals to pi. So this is also derivative function and then derivative. Part A. dy dx first. Now I see a outside function that's 2u times du dx. I think this is what I do. It's u squared, then 2u du dx. So I say 2u and then du dx like this. And then it's 2 tangent to x minus x. Now inside, we have two differentiation to do. The first one is very complicated because the first one is not tangent x, it's a composite function. It's tangent u and u equal to x. So I have secant u squared and du dx. And the second one is easy, it's just minus 1. So tangent to x minus x, secant to x squared, and d to x dx is 2. So my final answer 2 tangent to x minus x, 2 secant to x squared minus 1. And dy dx at pi equal 2 times 0 minus pi secant 2 pi squared. Secant 2 pi is 1. So 2 minus 1. Negative 2 pi. Part B. dy dx equal. The outside is 1 over 2 u to the power negative 1 over 2. And u is sine 2x plus 3. And then du dx. So dy du and then du dx. And then the inside. For this one again, sine 2x looks simple, but it's composite. It's cosine 2x and then du dx. So my answer this one is 2 cosine 2x. So it's sine 2x plus 3, negative 1 over 2 times cosine 2x. Simplified. And then substitution. Sine 2 pi, 0, plus 3, negative 1 over 2, cosine 2 pi, that's 1. So this is 1 over root 3. Okay. At this time, because this is the second lesson, and the third lesson for chain rule, the third lesson for chain rule. So with chain rule, I didn't show you all the steps. I didn't show you the pi, the u and the w and x. But basically, I'm skipping all the steps now. You must know that I am using the composite functions. You try to follow. If you can finish the exercise, then it's okay. You try the exercise. When you're done, you let me know by raising your hands and turn on your cameras when you're doing so. Emily Chan, why don't you turn on your camera? Okay, let's check the answer with some of the students who have done. Hey, part A, what is your final answer?
I got -4.
Okay, I also got -4. Part B, Catherine, what is your final answer?
I got 0.
Okay, I also got 0. Okay, look at the answer. Now the first layer is a chain rule. This is dy du. This is du dx. Okay. And inside another chain rule, dy du, and then du dx. Technically, it's 3 layers. And the answer is -4. This one. This is dy du, and then du dx. Now the inside, you also have a dy du, and then du dx. Now this one, the second du dx is secant x squared. This is a weird one. The tangent x is secant x squared. I hope that's okay. And then I did simplify this answer. To me, in my opinion, I think a mixture of tangent and secant is okay. So this answer is already factorized, and every factor is simplified. That's a very simplified answer. And then you do the substitution. Next question. No, we don't have a next question. Then we're done then. Then we're done then. Except for the new rules introduced for the functions, sine, cosine, tangent, these 3 ones. And we're still using the chain rule, the product rule, and the quotient rule, basically. Look at the next page. For you, it's the next page. No. The next file. The next file. Hmm? 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 Sorry, the next file. Oh, yes. Thank you. Finally. I think I messed it up. 5.5 has 2 pages that are identical to 5.4, but underneath, that is after page 26, we still have page 27. I was scared that you don't have page 27. You do, you do. Now this one is the last kind of functions, if we're counting the different basic functions. These 2 are still basic. Exponential and log, they are basic. And we need to learn the rule for differentiation for these basic functions as well. Again, it's a mixture of first principle, the proof, and exercise, the exercise application. They are very different things. The proof is first principle, the exercise application. different skill set. Different skill set. If you look at the past year public exam questions, it's very likely the first principle question is one of the basic functions. Very likely. So I try my best to show you every kind, so you know how to find it through first principle. This one we've done before. We've done this before. Let's do it again. This is an exponential function. It's just the base is e. Okay. Of course, you have other exponential functions, but this one is very special. This one is easier. dy dx, not dy dx, dx, ddx, e to the power x equal, by first principle, delta x approach 0, e to the power x plus delta x minus ex divided by delta x. This time I'm using delta x. Like on Friday, I was also using delta x because I thought maybe you need to know how to use this one as well. And for this limit, you will take out e to the power x, and you're left with e to the power. And then we can split this into two parts. And one of them is safe. Now here you don't have to do any substitution because there is no delta x left. So it's just e to the power x. The other one is a special limit. And then you're done. Okay. Pay attention. This rule can only be applied to this very specific function, meaning that if you change the base, it's not the same. For example, if I change the base to 10, d dx 10 to the power x, you cannot say it's equal to 10 to the power x anymore. The base has to be e. Now, how to differentiate this one later on, we'll have example explain that. I think not just this rule. In all the rules we've learned, dd sine x, ddx cosine x, ddx tangent x, it has to be exactly the same, has to be sine x. So the result is cosine x. If it's sine 2x, then the result is not cosine 2x. Do you know what I mean? It has to be exactly the same. For this one, also the same. You can't change the base, you can't change x, you can't change anything. It's this very specific rule, only applied to e to the power x. And this function is very special because the derivative function and the original function are the same function. We have a textbook questions. So page 33, the textbook. When you're finished, when you are done, you raise your hand. Maybe I show you the book. Some of you may not have the book. But when I show you the book, the answer is already there. Anyway. These are the questions. When you are done with them, please let me know. Okay. Then some of the girls, if you are slower, later on, I think I'll give you more chance to answer questions during the lesson. Now these classwork are easy questions, I think. Basically, you just apply this rule for this function and plus another rule. Perhaps just the coefficient, perhaps just one layer of chain rule. Example 18. Find derivative with respect to x. That means dy dx. Okay. dy dx. This is e to the power u equal. So it's e to the power u. For me, this one's slower than for this one. Y equal e to the power u. U equal. For the first time, slower. dy du e to the power u. It's identical to the original function. And du dx, 3x squared plus 3. So dy dx equal dy du times du dx. And that is this answer. And then you're done. The final answer shouldn't be expanded. This one, I really hope it's not expanded because I want the exponential and the polynomial to be separate. Part B. This one, it's not so simple. I'm not going to use the u thing anymore. So dy dx is product rule times this plus this times this. That's dfg plus fdg. I hope you know what I'm talking about. Not dfg, it's f prime g plus fg prime. This one, 4x cubed plus 0. For the second differentiation, it's not a simple exponential, it's a composite exponential. So it's dy du and then du dx. So it's 4x cubed e negative 3x plus x4 plus 1 e negative 3x times negative 3. To simplify, you need to separate the exponential with the polynomial. So you take out the exponential, you're left with 4x cubed minus 3x4 minus 3. Perhaps I should rearrange it. Negative 3x4 plus 4x cubed minus 3. And then you're done. Then you do the classwork. I will ask some of you for the answer later. Okay. Now, Melissa, I just wanted to check up on you. Can you tell me your answer for part A? Melissa? What? Now, if you're not at home, you probably should just watch the video then. Interesting. How about Cassandra? Cassandra, can you tell me your answer for part A?
I got open bracket 2x minus 4 close bracket e to the power of x squared minus 4x plus 1.
Okay, that's good. For part B, Bailing, how about you?
I got e to the power of negative x times negative x to the power x cubed plus 3x squared.
I think correct. Part C. Chanhei.
I got 2x plus x cubed over 5e to the power x.
Not the same as mine though. It's not the same as mine, but I will show you in no time. This is my answer, girls. Please check yourself. Part A, my answer is the same as Cassandra's answer. It's this polynomial multiply the original function. I think it's simpler for this one, part A. Part B, it's a product rule, right? It's a product rule. And I think Bailing's answer is also correct. I think she rearranged it. Like this. It's fine now. Because there are only two terms, so it's not a big deal. Now the final one, I don't think Chanhei's answer is the same as mine, but I'll check again. It's a quotient. It's a quotient, and it's d high multiply low. I'm just copying low. And then d low multiply high. Yeah, I think so. I think so. So it's, and then this is the answer for d low. Now this function is very weird. You just differentiate and then you get the original function because the derivative and the function, the primitive functions, they are the same one. And then for simplifying, it's tricky because I will take out e to the power x and 5. I'll take out and then I can delete one of them. So the final answer in the numerator, you don't have e to the power x. It's just in the denominator. The simplifying maybe something tricky here. Moving on. So I think this part is similar to the sine and cosine. You just learn this one rule and then you apply it in combination with the previous, the already existing rules. It's a mixture of all the rules. Next one. This one is a mixture. Two kinds of functions. E to the power x times sine 8x. dy dx equal now I'm just going to pretend I'm using the product rule just to show you, oh, I'm going to use product rule now. And then for the first differentiation, the answer is itself. For the second differentiation is the rule we learned on Friday. This is sine u, sine u du dx. So sine u, cosine u, and then du dx. As for the final answer, again, it's the same mindset. You take out e to the power x, and then you're left with a mixture of sine and cosine, but that's fine. Because they belong to the same family. Your final answer is one part, a factor of exponential and a factor of trigonometric. Classwork. Classwork is harder. Okay, this time maybe I ask Sophia Yang. What is your answer, Sophia?
It is 3e to the power negative x secant square 3x minus tangent 3x multiplied with e to the power of negative x.
Did you not listen to me about separating the two kinds of functions in your final answer? Your final answer, e to the power x, should be just one factor, and then the other factor is a trigonometry. Okay? You take out e to the power x. Sorry, e to the power negative x. Now, when I present the answer, I try to show you everything. I try to show you that I'm using the product rule now, right? Sorry, I missed out something. I'm using the product rule now, and then I'm using the chain rule now. Of course, when you are doing it, you're probably just gonna write the third line directly. I think at least half of the students should be able to write the third line directly. Not easy, but if you still need a few steps, you can learn how to write the steps to help you. Okay, you can write the product rule. You write down the product rule, and then you write down the chain rule to help yourself. But if you can skip all that. You can write the third line. And then the final answer should be vectorized. Moving on. Oh, we have more. I didn't know we have more. This one you have the answer already. Now I'll give you more time. If you are done with these two, can you raise your hands too? I'll quickly. This one I'll do quickly. I will do quickly. When you are done, you let me know. So I will stop waiting. Okay. Now pay attention because you're new to this. For part A, I still show you the chain rule. For part B, I didn't show you the chain rule, but you can see the trace of it. Because I did 2u times du dx. There is 1 plus 0 there. It's very subtle there. It's very subtle there. You have to do x plus 1 prime, basically. For this one as well, this thing is also a chain rule. So because the composite function is everywhere, so it's like everywhere you have to apply this. Although this lesson is about differentiation of exponential function, but that I think chain rule just steal the focus. It's almost there, right? Because the exponential is very easy, and then just the functions, how they are constructed. The structure is the most difficult part. Next kind, okay. Log. This one also we learn 1 log. It's just log to the base e, ln. The other base, as to the other base, we don't know how to differentiate, basically. Later on, we'll have examples about it, so you can know how to differentiate them. The first part is also about, I'm gonna show you the rule using the first principle as a practice, so that if it's in the exams, you know how to do it. ddx log x equal log x plus delta x minus log x divided by delta x. This one is, it's just a lot of log. You have to just know how to do it. I think I've shown you a very similar question at least before. You see, this is log minus log. I will change it to 1 log. And then this is divided by delta x. I will just do 1 over, so it's easier to write. And then I'm going to do 1 over delta x log 1 plus delta x over x. Okay. And then this is equal to basically ln 1 plus delta x over x to the power 1 over delta x. This is another property of log. And then I think you see where this is going. I think you see where this is going. This is to do equal limit delta x approach 0 log 1 plus delta x over x, and then this is sorry, I need to change this to, depending on which one I'm using. This one is x divided by delta x 1 over delta x, and then ln 1 plus 1 over x over delta x, and then this is x over delta x to the power 1 over x. Okay. Because this is what I'm gonna do. I'm gonna switch the limit and the log. This is log limit. This is 1 plus 1 over x over delta x and x over delta x to the power 1 over x. And we know this is log e to the power 1 over x. And that is 1 over x times log e equal 1 over x. Now this one, the proof is much longer than the exponential one. I'm sure there are shorter ways. But the thing that shorter ways to do this doesn't mean you prove it differently. It's just the presentation is different. In some methods, I will present it differently, but I'm using the same thing. Basically, I'm using this, what do you call? The definition of the number E. The definition of number E. I shouldn't highlight here, I should highlight here. And you can see me do that, plan this. You can see me plan this ahead, way ahead. Like why do I make them, why do I use the log property, right? Why do I do it this way? Why do I put it inside? And it's all planned. It's all planned. Anyway, this is how you get the differentiation rule for log x to the base e. Okay. The classwork, there is an easy classwork in the textbook on page 36. When you're done, you let me know. When I show you the answer already. Now, I think maybe some of you are stuck here in the last question. It's funny. Let's talk about question 2 and 3 first. It's funny that the answer is so different. You see? This one is 4 times log. So the derivative is 4 times 1 over x. So 4 over x. And this one is 1 over x. Somehow there is no 4. Isn't it weird? There's no 4. It's like it doesn't exist. And then in question 5, you can see why there is a 3 there, right? Because of chain rule. This is 1 over u and du dx. There is a 3 there. Now, but for the last one, it's so difficult. Let me show you this time. Log 1 over 2x minus 3. Where do I write? Maybe whiteboard. Y equal log 1 over 2x minus 3. dy dx equal dy du and then du dx. Isn't it? It's dy du dx. Therefore, simplify. And then for this one, it's d high low minus d low high divided by low square. So to further simplify, it's 0 minus 2, 2x minus 3 squared. It's negative 2, 2x minus 3 in the end. It's quite complicated, to be honest. Because inside the log u, and u is a fraction, u is the quotient itself. And that's how you get it. Maybe that's why you're stuck here. That's why you're stuck. The rest are, I think, fast. The rest question, they're very short. Sorry, not fast. You can do it very fast. However, I don't know if all of you have noticed, you can still make very good use of the log property. And here in this question is a great way to do so. It's a great way to do so. Please write this down. Y equal log 1 over 2x minus 3. That is negative log 2x minus 3. You can simplify first. A lot of the times, if you want to do the differentiation quicker, you can change the original function a little bit, and then you differentiate. Now you differentiate dy dx is negative dy du, and then du dx. And then you get the same answer. Do you see what I mean? Probably use this a lot in your homework, okay? Use this as much as possible to make your differentiation simple. Let's come back to the notes. Example 20. This one, A. Every time. A. Y equal log x. Sorry. 3x plus 2. I'm going to change it to log x minus log 3x plus 2. I think it's easier this way. So dy dx equal 1 over x minus 1 over 3x plus 2 times 3. So it is basically x 3x plus 2 and then 3x plus 2 minus 3x. It's 2 over x 3x plus 2. I think it's simpler this way. Part B. Y equal log root 2x squared plus 5 again. I'm going to take out the square root sign. So it's simpler. Dy dx equal 1 over 2 times dy du and then du dx. Last one, last one, I don't have a trick. See, dy dx, there's nothing to simplify, so I just do it. Product rule. And then 3x squared log x plus x squared. For this one, it's okay to be like that, but I will just take it out now. So probably in this classwork exercise, you should use the log property first before you differentiate. Otherwise, it's just too long. When you're done, let me know. Okay. Now, if you don't use the log property, probably there's not enough space. No. For part A, the answer is 20x plus 13 divided by the two factors. The answer must be simplified. Some students will leave the answer like that. It's not wrong. Now, if you ask me, Ms. Chen, if I leave my answer like that, will my marks be deducted? I don't think so. It's fine. But my concern is that in chapter 6, you will not perform well. Because later on, after differentiation, there are tons of things we need to do. Do you know? This is not the end. We differentiate for a reason. Later on, I'm going to use this. And if your answer is like that, you probably cannot carry on. So right now, you practice how to simplify. And for part B, this is the answer. And for part C, also you practice how to simplify this one because I need to show you. This one is new. But although I think I've shown you this technique before. You see the D high low minus D low high, right? And there's a chain rule there. This is D high. And then you see you have a fraction inside a fraction. How do you get rid of those quickly? That place, this is what I do. And this is not very common method. By common, I mean it's not commonly practiced at school. But you take out 2x. At the same time, you also take out this numerator. And then you put it inside later on. You learn this technique. It will help you. It will help you. So if you do that, then you will quickly simplify x and x to the power 4 and leaving x cubed in the denominator. And then I think it's simplified. For this bracket, I don't want you to expand because after expansion, you will have 2 logs and we don't want that. We want as less as possible. Okay. As few as possible, sorry. As few as possible. Now, look closely what answer is the desirable answer. Next question. Differentiate with respect to x. It's a mixture again. dy dx equal dy du and then du dx dy du okay. Final answer, -2 sine x cosine x divided by 2 plus cosine x. Leave your answer like that. Now you may ask, oh, should I change this to double angle? Should I, because I see I can use the double angle formula. Do not, do not. I think I want the angle to be simple as well. Okay, later on, if you need to, but in this question, you totally don't need to change the angle. Don't. In part B, dy dx equal. Now, some people see this as a quotient. I don't see this as a quotient. I see it as a composite first. It's u cube first. So 3u squared, and then du dx. I see composite first. Now, if you see the quotient first, then our method will differ. And then I see the quotient. That's d high low minus d low high divided by low square. Now for this square, you either write it here or here. Do not write on top of x. You write it on top of log or you bracket square. Okay? And then you simplify. For this one, you will take out, again, you will take out e to the power x and 1 over x at the same time. So it's e to the power x times 1 over x times, this is x log x minus 1, and then divided by log x squared. Okay, so final answer, you write all the denominators at the same time. All the denominators are 1x and then log x to the power 4. Yes, 4. 4. And then I have the numerator, we have a 3. We also have e to the power x, e to the power x, e to the power x, so e to the power 3x. And then we have this huge bracket, x log x minus 1. Usually it takes a while for you to get the answer. It's not the differentiation that's so difficult. It's to get the right answer. It's very, very, very hard. Now try to learn this method. Try to learn this method. If you need to have another look at this, maybe I can't show you anymore. But try to learn this. And then you practice. You do the classwork and you let me know. Okay. Look at the answer. For part A, this is the answer. For part B, remember there is a 3. Now for part B, the simplification part, I do chain rule first. This is I think this is how I'm gonna do it. If you do the quotient rule first, I don't know. I don't know. It's just too difficult for me. I think the chain rule first is better. And then, now this is D high, this is D low in the quotient. And then you still have a fraction and all these. And to simplify, this is how I simplify. Look here closely. You see how I take out e to the power 5x divided by x. You see how I take out that as a factor. And then leaving 5x. This is the most difficult part, I think. Because I took out 1 over x, I must multiply x to compensate in the first term. That's why there is a 5x there. And then my final answer, I will write all the factor just once, each factor once. For this factor, I think it's everywhere. It's an e to the power negative, e to the power 5x to the power negative 1 over 2. There is one there and one there. It's one here and one here. And then I put them together. This is one factor. Another factor, right? And then for this one also, I have log 7x squared. I also have log 7x to the power negative 1. And then I put them together. And that's the final answer. Okay. Extra example. Extra example. It's the end. Find the derivative of the function with respect to x. That's just dy dx. Now here I don't say derivative function because it's just in short, derivative function and derivative, sometimes we just use them interchangeably. Derivative function. Dy dx is equal to 4 log 2x cubed and then du dx and then 4 log 2x cubed du dx. Another chain. Do you see? I hope you see. I hope you see. So this one is also a 3-layer, I guess. 4 log 2x cubed 1 over 2x times 2. Final answer 4 log 2x cubed divided by x. Not particularly different, I guess. Class 4. It's also a lot of layers, I think. And this one, when you're done, you let me know quickly. Okay. I think, yes, I remember now. The extra example here is just to show you multiple layers of the composite functions. And for this one, the class where the outside one is a power function. And then the middle one is a log function. And the innermost is a polynomial. And that's the answer. That's the answer. Before we end the lesson, I think it's time to address two problems. The first one is how to differentiate 2 to the power x. Let's go back to page 27. Now we've done the whole lesson, almost 2 hours. And we learned to differentiate exponential function. What if I change the base? How do I differentiate 2 to the power x? D dx 2 to the power x. Is it equal to 2 to the power x, just like e to the power x? No, no. Unless you want to do the first principle. I don't think even the first principle is gonna help. How do I work out this? Now in this lesson, I'm going to introduce, perhaps maybe I wait for, maybe some students already know. Now in this lesson, we're going to introduce a method to do this part, to solve this problem. In later lessons, we have other methods. But in this lesson, how do we solve it? What if I change the base? It's not e anymore. Who knows? Some of you learned in advance from some other lessons. Any idea? Or if you know the answer, you'll also let me know. Yeah, Emily knows. Emily knows. Yes, this is very uncommon, but so far this is the only method I know. I mean, we can talk about now. That is to change the base to e. Of course, changing the base to e is going to cause some damage, right? It's not easy. How do you change base to e? If you want to change the base to 4, maybe that's okay. But to change the base to e, it's a lot of damage. Huh? Now this is how I change the base to e. Because I know 2 equal e to the power log 2. I'm going to use this identity. Not just 2, I can change any number to the base e. Like I can change 3. Now, if you don't know what is equal to, now you say e to the power what, right? And then what must be log 3. right? Therefore, 3 equal e to the power log 3. And 5 equal e to the power log 5. 10 equal e to the power log 10. Log meaning log to the base e, okay? You change the base to e, and then you change the power to log to the base e. And then that's how it's done. So it's d dx e to the power log 2 times x. Therefore, it's e to the power log 2 times x times log 2 times x prime. Chain rule. Now it's e to the power u du dx. You see, this is u. U. So this is e to the power log 2 times x times log 2. Now to simplify, so this is already done after differentiation. So to simplify the answer, this is 2 to the power x times log 2. Because I'm going to change this back to 2 again. This is 2. Sorry. This is 2. I'm going to change it back to 2 again. At the beginning, I changed 2 to e. At the end, I'm changing e back to 2 again. That's how it's done. That's how it's done. If you are okay with changing any number to the base e, then it's okay. It's not easy though. You try to savor this method. How do you change a number to base e, a random number to a base e? Okay, so that's half of the question answered. Another one is the log one. What about if I want to differentiate some other log, let's say base 10. How about this one? D dx base 10, not base e, but base 10. How do I do that? This one, what do I do? I think this one is relatively easier. What if it's base 10? Iris, what do you say?
Just use the log property to change the base.
Can you tell me how to? What base do you want to change to?
E.
E. That's a correct choice. Let's change it to E. This is log x divided by log 10. That's how you do change of base. You want to change base E? You see both of them are base E now. So it's log x, log 10. Okay. And then you can take out log 10. And then you have 1 over log 10 times 1 over x. So if it's another base, also change of base, but it's log change of base. Previous one is the number changed to power power of e, power of e. This one is log changed to log to the base e. Okay, that technically any base is the same method. You can change. You can do log x to the base 2. You can do log x to the base 5. As long as you know how to change this log to base e. This is the change of base formula in log. That's all. Bear in mind, in the exam, it's very likely that the exponential function is not in base e. Okay, but like I said, this is one technique, one method to solve it. There are other methods to find the derivative. Now later on, we will talk about those. But this is one way to go. Both for log and exponential, we can do another base. But the log to the base e and the exponential to the base e, those are the two basics. They are the basic functions. Yeah, that's it. I also want to remind you, I don't know why you don't get the notification when I upload the video. The locus extra example video is already uploaded, I think a few days ago. I think you should watch it. Let me know. Let me know. Monday, you also bring the notes for M2 to school. Notes for M2 to school. That's all. You can leave if you don't have any questions. Bye bye.